So, good morning to one and all. My name is Shalan Siddiqui. Today we will discuss about column. First, I would like to introduce about the column and struts. First, column. What is column? Column is a vertical member in the structure. In any structure in the building. I'm saying in any structure in the building is called column in the vertical member. Only in the vertical member. Just like that. This is a column and you can say that this is a footing. Now the second thing is strut. Strut is basically what is strut is the short column, or you can say that the column which is in inclined member in the structure is called strut. These are known as struts. Now, next thing is what is short column and what is long column. If we talk about short column, the ratio of short column is L upon D ratio is less than 12. If L upon D is less than 12, this column is known as short column. L is the length of the column and D is the depth or dia of the column. Now the second thing is long column. L by D ratio is greater than is 12. That column is known as long column. So we can say that if we talk about or if we determine about the column, we will calculate L by D ratio and compare with 12. If the column is less than 12, then the column is short column. If the column is L by D ratio is greater than 12, the column is a long column. Now I will draw one column. You can imagine it. This is a column. This is a steel bars, vertical steel bars. Vertical steel bars, and this is horizontal ties. Horizontal ties. The ties are helpful to tie up the vertical steel bars. This is tie bar. This is vertical steel bar. Vertical steel bar, and you can say that this is main bar. And now one thing is that this is the difference from one tie to the second tie is known as pitch. This is the distance for pitch distance in the column. Now second thing is we will discuss about two types of column. First is axially loaded column, means uniaxial column, and second is biaxial column. In uniaxial column means that the load which are propagate and equally distribute to all over the column. And the second is biaxial column. In biaxial column means eccentric load. Eccentric load will act on that particular column. So the formula for uniaxial column is PU. PU is the load of the column. PU equals to 0.4 FCK AC plus 0.65 Fy ASC. FCK is the characteristic strength of concrete, AC is area of concrete, Fy characteristic strength of steel, and ASC area of steel bar in compressive zone. Now the second thing is the formula for biaxial column is PU equals to 0.45 FCK AC plus 0.75 Fy ASC. Now the same thing is that the FCK is characteristic strength of concrete, AC is the area of concrete, Fy characteristic strength of steel, and the last thing is ASC, area of steel in compression zone. Now how we will determine that which formula will apply on a particular question? Now for this we will calculate if the ratio of 0.05D is greater than E minimum. E minimum is eccentricity of the column. So we will apply uniaxial column. So we will go for the load for uniaxial column. This is the formula. Now the second thing is, if the ratio 0.05D is less than E minimum, so we will go for biaxially column. Now next thing is, we will determine the end conditions of the column. This is a basic condition. So end conditions of column. In the end conditions of column, we have four types of end conditions. First is both side, or you can say that ends are hinged. Both side end is hinged means, for example, this is a column and both side is hinged. So if we apply the load on a particular column, the column will bend, or the effective length will look like this. This is the actual length L and this is the effective length LE. So the formula for effective length is L equals to L in the case of both ends are hinged. Now the second one is one end are fixed and the other are free. So in this case, we will draw first column. This is the column. We will apply the load from here. This is fixed, and the second one is free. So this is the actual length L, and when we apply the load, the length for effective length will look like this. This is LE, and the formula for one end is fixed and the other is free is LE equals to 2M. These are the two cases. Now the third case we will discuss is both ends are fixed. Third one is both ends are fixed. In the both ends are fixed means that this is the column. Both ends are fixed means upper end and the lower end are fixed. When we apply load, this is the actual length is L, and the effective length when we apply for is look like this. This is the effective length, and the formula for both ends are fixed is L equals to L upon root 2. And the last one is one end is hinged and other is fixed. So this is a column. This is one end is fixed and other end is hinged. Though when we apply the load on a particular column, this is the length L and this is the effective length of particular column. This is LE, and the formula for both end, one end is hinged and the other is fixed is L equals to L upon 2. These formulas will help how to calculate the end conditions of the column. So next topic we will discuss in the next video. We will discuss one type of column. This is circular or the square column. So this is up to you. Thank you everyone.